Hello, geometry students. Today we are going to be learning how to prove statements about segments to be true. Throughout this section, we're going to learn how to justify about the congruent segments and write reasons for the steps in a proof. We're going to also learn about two-column proofs, and we're just going to practice getting better about them. Some of the vocabulary I wrote out for you. You might want to take a minute and pause the video and copy them down for yourself. But a theorem is a true statement that follows a result of other true statements. A two-column proof is a type of proof written as numbered statements and reasons shown in logical order. And a paragraph proof is a proof written in paragraph form. A proof is just going to justify why you are able to show things are congruent or why you're able to make certain conclusions about statements in math and in life. Some of the properties that we learned about before, I think in the previous section, were the reflexive, symmetric, and transitive properties, and those are of equality. Now we're going to talk about them in terms of segment congruence. So for any segment AB, the reflexive property states that AB, or segment AB, is going to be congruent to segment AB. Again, the reflexive property is kind of like looking in the mirror. It's the same thing on each side of the mirror. You look in the mirror, you see your reflection. The symmetric property is AB is congruent to CD. So if that's true, then CD is going to be congruent to AB. You're just taking your statement and you're flip-flopping it. It's kind of like if you, and I think I used this example the other day, if you had x is equal to 7, then 7 is equal to x. That would be the symmetric property. The last one is the transitive property, and this is similar to the law of syllogism, where you have the middleman. If segment AB is congruent to segment CD and CD is congruent to EF, then you can conclude that segment AB is going to be congruent to segment EF. So what we're going to be doing is using these properties to set up a two-column proof. If you shift down in the page a little bit, actually below to example 1, I'm going to make this a little bit higher so you can see both of these at the same time. Example 1 is going to be our first example of a proof. And you can see there's two columns. This column is going to be the statements. This is what you know. And this column is the reasons. This is why you know it. It's really going to break it down, and you might be able to look at the problem and say, I can see that they're congruent, and I know that it makes sense. But a proof really just breaks down that thought process on why you're able to know this to be true. So along with the picture, they're going to give you a given, and that's what you know about the picture already. So for example, here they told us that JK is congruent to MN, and we also know that MN is congruent to PQ. What I would recommend doing when you do these proofs is draw tick marks or draw on your picture so that you can interpret what's going on here as you do the proof, which I will do in a second. So given this information and all these pictures, what they want us to do is to show that JK is congruent to PQ. You might already know it. So here's a general breakdown of a two-column proof. The first thing is really just to state what you already know, and the reason is always given. How easy is that? It's really going to be those two steps to begin with. So we know the following because it was given to us. The one thing that is actually going to pop up all over this section is whenever you see the congruent sign go to an equal sign, that's going to be the property or definition of congruence. I had you guys write it down on the last section. But you might want to write it down again. If we know that AB is congruent to CD, the definition of congruence helps us go between these two things. It says that we can rewrite it as AB is equal to CD, and vice versa. So say we start with this and go to the congruent sign, you would use definition of congruence as your reason. All right, so all they did is they restated the same thing, but the congruent signs changed to equal signs. So this is the definition, and I'm just going to call it DEFN of congruence, and I'm just going to use the congruent sign to save some time. Step 3, now we need to figure out what's going on. They told us what the reason is, and it's the transitive property. So if you kind of visit up here what that transitive property is, we might just need to rewrite it so that the letters fit our problem. So somehow we need to use the transitive property, and we know that JK is congruent to MN, and MN is congruent to PQ. I see a middleman right there. So I bet that we can say, because of the transitive property, that JK, if we just, get rid of the middleman, that JK is equal to PQ. And you can kind of go back up here. Here's our middleman. We can cancel him because he's overlapping and conclude that JK is equal to PQ. The last statement, again, just goes from the equal sign to the congruency sign, right back to the definition of congruent segments. You can just write definition of congruence. I will take that as true. All right, so there's one example. You might want to pause and discuss this with the people next to you. All right, so here we are. On to the next one. Our next example, given our information, has that PQ is congruent to RS, and that PQ is also congruent to QR, and PS is congruent to RS. A lot of different letters going on here. So let's just kind of look at what they said. We know that PQ is equal to RS. That is part of our given. So that is why we can write given. PQ is congruent to QR. That's also part of our given. So we can just write given. Now they wrote this in for us, but let's just see if they're right. This is just part of, understanding the problem. So PQ is congruent to RS. I'm going to write little tick marks in there. PQ and RS. PQ is also congruent to QR. So then this is equal. So then they say that RS is congruent to QR. So that means that this segment is equal to that segment. And that does make sense because in this last part, PQ was that middleman. So that does work out that it's the transitive property. All right, so then they hopped over to PS is equal, or congruent to RS, and that is also part of our given. And this says that PS is congruent to QR. Again, you have this middleman that's overlapping between these. So you're good to go. Transitive property. That one wasn't so bad because all of our fill in the blanks were the givens. Let's try. We have two more. And I am going to go through them with you. So it says, in this diagram, we know that AC is equal to CE. And AB is equal to DE, and we need to show that C is the midpoint of BD. So it's a lot of information. Let's just place the right things in the given and the proof. The given, again, is what we know. So we do know that AC is equal to CE. We know that AB, I'm just going to write a comma in front of it, is equal to DE. We need to prove that C is the midpoint of BD. All right. So looking at what they have, AC is equal to CE. That matches what we were given, so we can just write given. I'm going to mark up the page as we go. So we know that AC is congruent to CE. So the big segments. Okay. So now the next statement says something about how AB plus BC is equal to AC. And we dealt with this a little bit in the homework from 2-4. But if we kind of look at what this is talking about with the picture, We're talking about this segment added to this segment equals the larger segment. And you might remember that that is segment addition. I'm trying to make an announcement. All right, the transitive property. So we somehow need to use the transitive property, which means that there's going to be some middleman between these two. If I look up in the proof, it seems like AC is overlapping in these statements. So I bet what we could do is, since the AC is overlapping in statement 1 and 2, I bet we can conclude that AB plus BC, get rid of the middleman, is going to equal CE. So let's just see what this means for up here. So AB plus BC is equal to CE, so this whole thing. Okay, that's getting us somewhere. All right, let's check out what's going on over here. So we know that CD plus DE is equal to CE, according to this. And this is actually the same as what we did in number 2, where we take the segments and we're just adding them. So this is segment addition. After that, we have to use the transitive property again. So what I would do is look up into the steps for 3 and 4 and see if there's some sort of middleman, or see if there's something that's overlapping. Personally, I see that CE is the same for both of these. So what I'm going to do, since CE is the same, and this is all equal to CE, and this is all equal to CE, then I can conclude that these two things are equal. And that is the transitive property. Okay, so the next thing, AB is equal to DE. At first, I would be really confused as to how this is related to this. So what I'm going to do is kind of go back to what they gave us, and looky there, it's right there in part of the given. The next thing, this statement looks a whole lot like this, but let's just double check. It says that AB plus BC is equal to CD plus AB. It looks a whole lot like this statement, but what changed is that they changed DE and they rewrote it as AB, probably because of this statement right here, because these two things are equal. When something happens like that, when you replace just one part of the segment, one part of the statement with its equivalent part, this is an example of substitution. All right, so then what we need to do is just look ahead. They want us to subtract something from each side. So I noticed that AB is on both sides, so I'm going to just subtract it, and I will show my work. You don't have to in your proof. But if you subtract AB from both sides, you are going to get that BC is equal to CD via subtraction. And then they want us to use the whole definition of congruent segments. You might remember that it just takes the statement and puts a congruent sign in it with segment signs. So let's see. It says that BC is congruent to CD, and I'm going to go ahead and add little tick marks in there. And are we able to conclude that C is the midpoint? I mean, if BC is equal to CD, then that means that C is halfway between B and D. So we are able to say that C is the midpoint. And that reason would be definition. Again, I'm just going to use DEFN of midpoint. I am going to do the last proof on a different video. Thanks for watching.